Sorry.
So I'm going to say something which will probably get edited in the final edit. But I mean, you must have heard this very famous joke on this boldly go where no man has gone before. Yeah, the answer to that is the woman's loop.
But today that is not.
I remember this conversation that Brian Cox, is the astrophysicist he had, and I think I've talked about this before. He said that, when I go around the earth, first I try to find my village. Then I go around, I try to find Mecca, I try to in Saudi Arabia. But then I keep going round and round, I only see Earth.
Before he told me these types, being a Trekkie, hardcore Star Trek fan, the only thing I knew was Class M planet is where you can breathe. So it has an oxygen, nitrogen kind of atmosphere. So every Trekkie would know Class M planet.
Just a little bit of fun trivia and maybe a question for both of you. How many sunrises and sunsets do astronauts aboard the ISS experience daily?
Some 5 or 6 or something, is it?
16.
16.
Approximately 16 sunrises and sunsets. Can you imagine the kind of crap
Wow.
you must be going through?
Hi, I'm Nilesh. Welcome to 3TB, a podcast with 3 Techies Banter. It is a podcast where we can explore tech in a non-tech way. It is about talking about tech and economics behind tech. It is full of information, fun facts, common sense, and it is spoken in a language that everybody can understand. But today's topic, I believe, is something that would not have been a topic of conversation or at a social gathering about a decade back, right? It was not a common topic. It was a topic which would be, kind of people disposed in that industry would talk about, not people like us. You would not do engineering in this space. Only you would do engineering in this space if you didn't get computer science, mechanical or chemical kind of, and it would be like lower down the pecking order a decade back. You would not hear of a friend who did a startup in this space. You would rather hear them doing e-commerce delivery or a ride-sharing app or stuff like that. And the reason is because this topic was really limited to the domain of kind of superpowers, when the world was bipolar and, this whole Cold War era, India was not doing anything kind of in that space. If you have not guessed the space as yet, I'm talking about space, the final frontier, to boldly go where no man has gone before. And thanks to Jeff Bezos' Blue Origin, I was so happy to hear that our favorite Captain James T. Kirk did actually finally go to space, even if it was suborbital space. He took a shuttle to suborbital space with 2 paying members. So I'm sure the economics behind it worked out very well for Jeff Bezos and got him all the necessary, coverage that he finally took his childhood icon, Captain Kirk, to space, and he became the oldest man to go to space at 90. So today's topic is about space. And honestly, just to, because I started by saying that it's space, the final frontier, it has actually become everyone's frontier now. Kind of, it is not really the final frontier whereby there is a race between Russia and US. It's not like that at all. And aeronautical engineering is not like, okay, I didn't get computer science, mechanical or chemical. So okay, I live with aeronautical. It is no longer that, and it is not so far fetched. Whereby you might hear a friend's son doing something in space tech, a startup, beyond creating social media apps and stuff like that. So it has become a topic which is relevant today, and I thought we should kind of talk about this and get some more insights into this topic. So Samiran.
Nilesh, talking about insights, I thought your conversation was very insightful about the Indian parent. मेरा बेटा engineer है.
दिल के पास
दिल के पास का बोल दिया.
Sheepishly saying, कौन सी engineering कर रहा है? Aeronautical.
हाँ, अब दिल से बोलेंगे मेरा बेटा एरोनॉटिकल इंजीनियरिंग कर रहा है. So that really will connect with every Indian parent of our generation. But having said that, Samiran, you were saying something when I jumped in with insight. Sorry.
So I'm going to say something which will probably get edited in the final edit. But so you must have heard this very famous joke on this boldly go where no man has gone before. Yeah, the answer to that is the woman's flu.
But today that is not.
So
Samiran, you just gave away your age. In today's day and age, that is not a challenge.
Yeah, I agree. But then it'll stay and not get edited out.
No, now it'll get edited out because you're very passe, not because so many.
Too bad.
But Nilesh, you're absolutely right. There was a time when if you spoke about space, it was always the US versus Russia, right? And that used to be the two juggernauts who really placed. And I always think that when you spoke about the fact that it's not a conversation that would have happened in at dinner conversations in India, etc. And it's quite fascinating because in my head, at least, I thought India had joined the space race really late. Right. But when I think about it, we hadn't really joined it really late. We joined it very early, but I think our vision for space was very different from the US versus USSR in those days conflict, right? For them, it was about who goes ahead and puts that first flag and things like that. I think for us, and we went in early as much as, our space journey started in the early 60s, right? So in 1969, in the 1950s and 60s, is when everything was happening in the West. But in 1969, we actually founded our space program. And if you think about it, that's not really what we all are aware of. We always think of it as a recent phenomenon because everybody talks about the Chandrayaan and things like that. But as early as 1969 is when we started it. But what was more fascinating for me is like all things Indian, even the space program that we launched was completely grounded in, was grounded and developed for social development. Like, I can't think of the USA going into space for social development, but we in 1969 talked about going into space for social development. And the whole focus was on harnessing satellites for communication, for education, for weather forecasting, for remote sensing, and not for geopolitical showmanship, which is what the USA and USSR were all about. And I think that's what's amazing about this country, right? We don't do things just because it's a competitive piece. We do it because we think that's what works best for us. And you see that in every conversation we have, wherever we have it. And so you're absolutely right. It's not a conversation we did 10 years ago, but it's a conversation.
And Sheetal, you're so right that, it's people should know how old is our space program, because for multiple reasons. One is that, absence of social media influencers and stuff like that in that era. And second is the stuff we were doing, as you correctly mentioned, was not really glamorous, right? It was glamorous to put a flag on a this thing or put first foot on the moon, and then have those sayings of say landing man on moon and stuff like that. But yeah, we were doing stuff, and I think people should know that Vikram Sarabhai and people, the whole thing started way back, and it was for a social good, and not really for accolades which were more media friendly. But on the same, why it has become more relevant now is also due to the fact that it is, other than the fact that earlier it was just two countries, it has become a multi-country race. India itself is doing fantastic. I was so surprised to see that when you look at Southeast Asia, a country like Indonesia is at forefront. So Indonesia also has a very long-standing, space program. They have Lapan 1 and 2, satellites, and again more for monitoring Earth or environmental parameters. But I think Southeast Asia countries like Indonesia, Malaysia, obviously Japan, Vietnam, multiple countries are in this.
Oh, absolutely.
So, in fact, Saudi Arabia has got an astronaut actually. So in fact, space gives you that perspective. And I remember this conversation that Brian Cox is an astrophysicist he had, and I think I've talked about this before. So he said he's spoken to a whole bunch of astronauts who have gone into space, and the one enduring or consistent thing that he finds is that, and he was talking to a Saudi Arabian astronaut. He said that when I go around the Earth, first I try to find my village. Then I go around, I try to find Mecca, I find in Saudi Arabia. But then I keep going around and around, I only see Earth. And then you start realizing that this is the one place that you have, and this is the only thing in the vastness. And the corollary to that is that Brian Kirk said that as soon as politicians are elected, they should all be sent into space, so that they get the same perspective. And he kind of got into a little bad press because they asked him, should all of them come back? And the answer was maybe most of them, not all. So, but I think the vastness of it also gives you a perspective as to, this is your only planet and all. And of course, there is the exploration outward angle. But when you go out, you start looking at it and, this is the little dot, that's all we have. I think that is a good way to solve. We should probably send Putin and Zelensky and everybody into space once.
But don't start the war in space before we get to space. So let's not send all of them out. Let's send the lesser aggressive.
Let's just go and gaze at Earth.
But when you think about it, it's also the size of this entire business, if I may call it that. So if you think of the economy of global space, it is massive. It's $596 billion. And one never thinks of it like that because we see it in such a scattered form that we don't see it. And what's amazing is that there are parts of it which are big. And like you mentioned, today, everybody's a player. So while North America leads with $86 billion of it, you now see MEA, Asia, all of them coming in with so Asia's at $45 billion, MEA is at $18 billion. So you are seeing that there is a certain amount of money and investment that is going into this final frontier, or the new frontier, if I may call it that. I'll call it new frontier because we know Samiran's favorite thing of shipping everyone off into space, letting Earth heal, and then shipping people back. I have another one on that, Samiran, but maybe in another segment. But it has so many aspects. But a $596 billion economy is a massive, massive economy that we're dealing with. And that's what really is fascinating about
and I think since we were on economics, I thought it's kind of, since we are bringing it to a drawing room conversation, people should be I think people are aware thanks to movies, Akshay Kumar acting into movies and bringing it to the audience. People are aware, but just to put it in perspective, I think the India, ISRO did it at a extremely low cost, right? So roughly it was $77 million, right? The whole Chandrayaan. The launch and stuff like that. While if you look at it, I don't think anyone has done it so cheaply. Even SpaceX, and we have to talk about the economics and talk about SpaceX, because what one of the trends that will happen is that can you reuse rockets, right? I mean, like an aeroplane, you don't discard a plane after a single journey, right? You reuse the aeroplane. Similarly, can you reuse rockets? They take the payload, come back, take another payload, and keep doing that. But even that one, the reusable one, the launch cost for Starship, I think it was called, was I think 67 or 68 million, right? After reusing, doing it multiple times. So India did at 77 million. So just imagine if India can create a reusable rocket, I mean, it will be order of magnitude cheaper. As a matter of fact, SpaceX itself, kind of says that they can bring down the cost of launch to somewhere between 2 to 10 million by reusing the rocket. So I think what ISRO has shown us how to do it better, cheaper, faster, I think.
Correct. We're very good at that. But there's also the other thing, right? So I think in 2024, the number of spacecraft deployments was about 2,400 or 2,500 or 2,800 maybe. And that kind of tells you how many spacecrafts are getting deployed. And therefore, the cheaper it becomes, I'm a little worried that too many will go out there and then we'll have other problems on our hand. But yeah, that's how much it is. And it's much more than what it used to be, even as early as 2022, right? So the numbers are just going up dramatically as far as the space frontier is concerned.
So I will, like my Bollywood departure, I will make another little fiction departure. Since Sheetal and I landed up writing this fiction book, I have been immersed in all this. So I found 2 or 3. The elephant in at least my room is there any life out there? so I dug up. So there are a whole bunch of governing theories here. Okay. So there's one, this is called the Drake equation. Okay. So he's the guy who started the SETI project and all. So he's actually come up with a probabilistic model as to the chances of there being intelligent life on the in the Milky Way. So there is a whole set of variables which can, there's a product, is like, when was the planet formed? When was the star formed? When was the planet next to it? Is there life? Is there intelligent life? And the probability of that. And it comes up with an output. Obviously, it's not been solved or nobody there, but it kind of gives you food for thought. So, and Drake went on to kind of do a lot of work in the SETI project. Didn't discover anything, but that was that. The second fun thing I found was the Fermi's paradox. So Enrico Fermi, of course, he did a lot of other things, but just on a whim, he had said that if there is intelligent life out there, why haven't you discovered it? So people have spent 50 to 70 years trying to solve this paradox. Okay, and some of the solutions are that there is actually what we call a great filter, which means that there is a point beyond which civilizations don't grow. So they die. So you'll never discover them because they never become so great that you'll find them. Second is called the zoo hypothesis. They say that the more intelligent civilization treat you like zoo animals. So they just pass you by without looking at you. So that's the solution. And the third one is called the dark forest theory, which is that people are so scared of being discovered, they stay very quiet. So even if you send out a signal, nobody responds. So that is the Fermi's paradox.
Sorry,
No,
but
I'm just
why do people spend time doing this? Out of
This is
curiosity.
just to make it interesting. And there is another very crazy one called the Kardashev scale, which is it's got type 1, type 2, type 3. And I have no idea why I had referenced it in one article also. So type 1 civilizations are civilizations that use all the energy at their disposal in their planet. Type 2 are using the energy source of their parent star. And type 3 is all constellation. And Earth is below type 1. So it's like near a zero. So that's where we are. So this some crazy Russian came up with this scale in 1969. And now you can go on to space travel.
That is
Not
very,
doing
very
it.
interesting. Before he told me these types, being a Trekkie, hardcore Star Trek fan, the only thing I knew was Class M planet is where you can breathe. So it has oxygen, nitrogen kind of atmosphere. So every Trekkie would know Class M planet. So I think that brings us to end of our section on space, and I think we'll jump into some more interesting stuff in second section. I thought I should take a break because I don't know how we are going. Where are we going?
I have no clue what he said. Anyway, I'm going to come back. We'll talk about space travel.
We are back with segment 2 after that rather mind-numbing experience where we talked about type 1, type 2 planets, not to be confused with type 1, type 2 diabetes, but to more real things. I think the point was more to illustrate that it's a fascinating topic and people do anything they want with it, such as me. But the important thing to remember here is that as Nilesh and Sheetal both mentioned, that India, despite being a late starter, has done amazing work in this field. If you go back and look at India's space program, one of those endearing images is the Indian scientists on that bicycle trying to take that little satellite and rocket for a launch, and we've come a long way from there. And as like Sheetal mentioned, we are probably the only country whose primary objective was socioeconomic development, agricultural research, weather forecasting, self-sufficiency in various fields for its citizens. And I think we've come a long way. And now our program is recognized as a world-class one by both SpaceX and NASA and who have you.
And what's fascinating is despite the fact that we've done so much, we still stay true to our vision, right? We are not doing this just because we want to prove that we can be there. And the fact that we can, I think India's talking about developing over 100 satellites and developing its own satellite internet constellation in the future. That's what we're talking about. And it continues to talk about supporting strategic operations in the country, right? So we're still not going the way the West does, which is chest beating. It's not about that. It's still about supporting national strategic ops, and it could be coastal surveillance, it could be food and water security and things like that. So we are also building critical domestic manufacturing capabilities, right, for all of this. So Nilesh, you want to talk about some of the stuff that is likely to happen with
Sure. So, since we were on the topic of India, I read somewhere that just to conclude that while we are doing all this very interesting stuff, which is in the social development area, we are planning to actually send a manned this thing to land on Moon. And I think it is very close, right? Many people would, if you do it now, it sounds like, okay, but that happened in like 1969 or something, person landed on Moon. But yeah, that shows that there were multiple things to be done before there was value in just putting foot on surface of Moon, right? So India has really done fantastic job.
Correct.
The trends are very interesting, actually. When I think of trends in space tech, they are very interesting. Firstly, some have come out of the fact that there are too many satellites in the space. So there is a startup in Singapore which is going to work. It's Astro something, but it's I forget the name. It is about collecting space debris, right? So like we are creating debris on Earth, there is some amount of debris being created in space. So there is a one startup which is doing some work in that space. The While that aside, the interesting things that can be done in space, one I found out was actually manufacturing in microgravity, right? And when I read about it, it was so fascinating. We never think of it, that there are multiple problems with certain manufacturing elements due to gravity. One of them is sedimentation, right? Because of gravity there will be sedimentation. So if you create fiber, optical fibers, you have to manage sedimentation and uniform cooling, right, to get the optical fiber. And you can do it, create much more resilient, much more flexible optical fibers if they were manufactured in space, where there is microgravity or no gravity, right? So manufacturing in space is something that people are toying with that idea. Some elements of it have already been seen through there was 3D printing being done in space. 3D printer was sent to space. Then I think one of the European ones, I'm not sure which, they sent a metallic 3D printer in space. The idea being that astronauts who are in space can actually manufacture some of the things they need in space itself, or manufacture interesting stuff and send it back, right? And the problem with all this is always going to be how to send it back. So multiple elements are working. If you can get a rocket back, you can get stuff inside that rocket
Correct.
back, right? So manufacturing in space is an interesting trend. Other trends are, actually, I won't even say futuristic, they're already happening, which is very much GPS. So GPS satellites are there which help
Correct.
our day-to-day transactions. You try to it's not just global positioning, but it's global time also, right? So you need to synchronize time across your servers
Correct.
and stuff like that. So GPS is a fantastic trend. So a lot of work in the survey of weather patterns and surveillance in general of Earth. There are a lot of trends happening in that space. Samiran, anything you would like to add?
No, so I think, Nilesh, that just to take on your GPS point, that GPS is really a very US controlled system, because it's based on US satellites. And like everything else, it does give one country an unfair advantage in case of a crisis. So India, in fact, has got their own NAVIC system. While globally it is not as accurate as GPS, but in South Asia, it is as accurate, if not more. So, which is kind of a very big thing towards, again, self-sufficiency. And this, again, I'm not sure how true it is, but we are kind of going to the next level of pin codes. They have something called digi codes or something, where you can actually kind of drop a pin somewhere and kind of be accurate to a few meter,
Wow.
as opposed to a whole pin code. So those are, again, while not earth-shattering in terms of technology, but they're very, very important building block technology. That you're getting self-sufficiency in geopositioning. You're getting self-sufficiency, and of course in weather forecasting, we've kind of become much better. So those are the things, I think, which are very important to watch out for.
And since you mentioned this, it's very interesting. These small developments, right? Another one that came to my mind was these are they will give impetus in future. So one of them is also nuclear powered rockets, right? It's the work is happening that the reason being, today when you think of Mars, or deep space, the amount of time any probe will also take and come back is humongous. I mean, it's crazy, right? So they are thinking. So these are another elements which, if developed, will take space as the frontier, even bring it closer, kind of, right? So nuclear powered rockets is something, work is happening on it, and suddenly Mars can be like a couple of days, not like months and stuff like that.
So I kind of think of this space travel as like the Formula One version versus the regular automobile industry. It's like, we do so. It's like cutting edge stuff, right? But it's not mass. It's not commercial grade. You have to do it at a country level, a very large company. But what you learn there probably can be applied in civil aviation, drone technology, positioning systems. There's a whole lot of application even on Earth. As you refine the math and the physics of space travel, and I find that very fascinating. I mean, I kind of always think of that analogy of Formula One.
And you're so right. Sorry,
And so
he's so right. This
ahead,
analogy, Formula One versus normal cars. Actually, one other trend that is happening is people are just trying to figure out the sonic boom part of it. Can you create rockets to travel within Earth, right? The only issue is how do you control the multiple problems, multiple G's, but at the same time, the sonic boom. How do you control all that? And you may see, way faster transatlantic global travel happening using actually space technology. So yeah.
Yeah, I only a word of caution for both of you that while I'm super excited about everything that's happening, I just want to say that already there are like 130 million objects from 1 mm to 10 mm floating out there. And these could be anything, right? From little paint flecks from rockets to small fragments which are there. And even the smallest of these can create massive impact in the orbit, right? So they talk about the fact that most of the debris is located in Leo, right, where the ISS is located. And it says that there is so much activity happening in that space that even the smallest of things can have massive impact over there because of the speed at which the object travels. So all our problems with the environment that we are creating over here, we've already started multiplying them. I don't know how many X in space. So we've not sorted our own environment problems, but we're going to create space junk at a rate which is maybe faster. And we don't know how to deal with it. At least with some of the junk on Earth, we have some solutions in place. Space junk, I don't even know what we have.
So I think I see a positive there. It's probably hiding us from all those dangerous aliens that are looking for us. They'll think this is like a garbage planet. Now let's just go past it.
Yeah.
No, but I think the issue is that consequence, right? I mean, we kind of littered our oceans till the time somebody started saying, oh, sea life is dying and global warming. Because you don't think about, you think land is everything and that doesn't matter.
Correct.
At some point, space didn't matter because it's so big. What the hell? But I think that's
So that's my
going to be a
only
problem.
worry with space travel, because we're going to send people out there and we're creating more space junk. At least something was clean. Now we're going to
The rich will create one nice little highway through that junk. Everybody else will have to deal with it.
So that's my single biggest worry about creating everything on space and space travel. I think I'm always worried about it. Just a little bit of fun trivia and maybe a question for both of you. How many sunrises and sunsets do astronauts aboard the ISS experience daily?
I think maybe some 5 or 6 or something.
16.
16.
Approximately 16 sunrises and sunsets. Can you imagine the kind of crap you must be going through in a day? 16 sunrises and sunsets. And Samiran, this one was specifically for Samiran, given that he's such a dog lover. Did you know? Okay, who was the famous space dog that went into?
That's it, Laika.
Yeah, but did you know that there were 2 other dogs who went into space other than Laika? They were called Belka and Strelka. So the next time you're thinking of naming your dogs, you know what to call them. They were actually the first higher organisms to orbit Earth and return alive. So they were aboard the Sputnik 5 in 1960. So Laika is the most popular and the most famous one, but there was Belka and Strelka. Sorry, since you're a dog lover, I had to tell you that you could take Yumi into space if you decide to take her.
The last guy who took paid some $20 million or something. That's one way ticket. No way.
So on that happy note, Samiran, come on, you're talking about people traveling. You may as well pay for dogs also to travel.
Let them go. It's the same thing. If everybody is going away, then Earth will become clean. I'll stay back.
Okay. So to end this episode, we're going to give you one question, and I actually gave you the answer. So I'm not going to ask you this question. I'm going to ask you a second question, which is, how many Apollo landing sites were mapped by Chandrayaan-1's cameras? That's the question for you to answer on this episode on space technology. With that, we come to the end of another episode of Three Techies Banter. If you liked our banter, please subscribe, like, share, follow. You can also catch us on audio podcasts on every other platform. Feel free, have fun, and do make sure that you respond to our question. You may win a gift. See you another time. Thanks, guys. Catch you in the next episode.
Bye from me.
Captain's log, stardate 1709.2. Patrolling outposts guarding the neutral zone between planets Romulus and Remus and the rest of the galaxy received emergency call from Outpost 4. The USS Enterprise is moving to investigate and attack.